Okay, this is lesson 6.3, and in this lesson we're going to do more of the math that we did in our previous lesson. We used similar triangles to solve examples, but in this one it's going to be applications. So we're going to see how similar triangles are used in the real world to solve for unknowns. And we're going to do 4 examples in this lesson. I encourage you to stick around for all 4, but after the first 2, if you feel like you got a good handle on it, what you can do is try the last 2 on your own, and then check your answers on the course website. Okay, let's start with example 1. A surveyor wants to determine the width of a river. So here's our river. It's kind of messy here, but here's the width of our river. She surveys an area and finds the following measurements. She's got this length and this length and that length. She uses a pair of similar triangles to help her find her answers. So what I'm going to do is I'm going to label this triangle first. I'm going to call this triangle A, B, C, and I'm just going to continue with A, B, C, D, and E. So find the similar triangles. Well, we've got triangle ABC, triangle A, B, C, and that's going to be similar to another triangle. Now we have to follow in the same order. So A is this angle up on top here. So which angle in this triangle is angle A going to be? Well, it's not going to be D because D is the right angle. D and B are going to be similar. So actually the middle letter of our triangle is going to be D because the middle letter of this triangle is B. A is actually going to be E. So E is going to go first. And the reason A and E are the same is, well, because these two angles are opposites, C and C. So the C's need to match. If you ever label 2 angles with the same letter, it means that those angles are equal. So because C is shared, C's are going to match. D and B are our right angles, so that leaves A and E to match as our other angles. So there's our similar angles. Now let's write what side we want to find. Assign a variable to represent the distance we need to find. Well, we need to find AB. So we want to, that's step 1. Step 2, we want to find AB. And now we're going to solve it, just like we did in the previous lesson. So we're going to write our pairs of similar sides. We've got AB is going to be similar to ED, which is right here. And BC is going to be similar to DC. So it's BC and similar to DC. And now what do we got left? We got AC, our diagonal, is going to be the same as EC. EC. And now let's fill in the ones we know. Well, we don't know AB, that's what we're solving for. ED is 18.6. BC is 79.6. DC is 34.2. And we don't know AC or EC, so we can cross that one out. Now we just have to solve. So let's bring it over here. We got AB over 18.6 equals 79.6 over 34.2. And now this is nice. What we're solving for is on top, so we have less rearranging to do. We just have to bring the bottom up and multiply. And we can do this if the thing we're solving for is on top. If it's not, we have to do that whole cross multiply step and then divide. This is just one multiplication. And now we're going to type it in our calculator. So I'm going to use my fractions button to set up a fraction. We got 79.6 times 18.6 divided by 34.2. And we should get 43 point, round to 1 decimal, 3. And we're working in units, are meters. And there we have it. All right, let's try another one. A pole 3 meters tall casts a shadow 4 meters long. A nearby tree casts a shadow 15 meters long. What's the height of the tree? All right, so we got two similar triangles here. We've got A, B, C, and D, E, F. How do we know we have similar triangles? Well, the shadows are going to make the same angle at the ground, and we have right angles. So that means that this angle and this angle have to be the same. So our step one, find our similar triangles. We have triangle ABC, the same as triangle. Well, if it's ABC, that means DEF. Next step is to write our pairs, or assign a variable to represent the height we want to find. We want to find AB. So we want to know the height of the tree. And step 3 is to write our ratios. Now, we can look at the triangle to find our ratios. Another way is to look at our similarity statement. So the first two, AB, goes over the first two, DE. The second and the third, BC, goes over the second and the third, EF. That leaves us with one pair, AC, first and third, and DF. And that's how we can get all of our pairs, or we can just look at the triangles. AB, DE, BC, EF, AC, DF. One pair we're not going to use, that's the ACDF pair. We know nothing about that, so we can cross that one off. And we can just fill in what we know. We don't know AB. DE is 3. BC is 15. EF is 4. And again, we have our unknown on top, so we just have to do one step. Up and multiply. So AB is just going to be 15 times 3 divided by 4, which is, I can do this one in my head, 11.25, and we're working in meters. Now, I guess I should have written therefore statements at the end because we were working with word problems. So this one said, what's the height of the tree? Well, the height of the tree is 11.2 meters. And I forgot my word statement for the first question actually too. She surveys the area to find the following measures. Use a pair of similar triangles to help find the answer. She wants to find the width of the river. So we would say, therefore, the river width is 43.3 meters. Oops. All right, let's flip it over and we'll try two more. At this point, if you feel like you got the hang of it, try these two on your own and then check your answers. Otherwise, stick around. A hiker whose eye level is 2 meters above the ground wants to find the height of a tree. He places a mirror horizontally on the ground 20 meters from the base of the tree and finds that if he stands at point C, which is 4 meters from the mirror, he can see the reflection of the top of the tree. And now this actually works. We could do this in practice and it would work out. So here we go. We got a triangle. I'm going to call this A. So we've got A, B, C, and we're going to call this B, D, F. So find the similar triangles. Similar triangles are A, B, C is similar to triangle. I'll start at the top. D. B is in the middle. And then F is the bottom. The man and the tree are representing the same side in the triangle. Step 2, what do we want to find? Well, we want to find the height of the tree, which is DF. And now we can write our similar sides. So we're going to be a little bit more efficient in this example. We're not going to write the pair that we don't know anything about. And the pair we don't know anything about are the diagonal, AB and BD. So we're going to skip those sides. We want to find DF, so we're going to cheat and put that one on top. DF, and that's similar to AC. and we know FB and CB. All right, let's fill in. We don't know DF. AC is 2. FB is 20. And BC, or CB, is 4. And there we go. We've got it again with the unknown on top, so we can just bring this up and multiply. And we end up with DF equals 20 times 2 over 4. 20 times 2 is 40, and 40 divided by 4 is 10. 10 meters. That tree is 10 meters tall. There we have it. Therefore, the tree is 10 meters tall. All right. The last one says practice, but we'll give it a shot together. Or if you'd like to stop now, you can try this one on your own. This one's tricky because we don't have a diagram. Sarah needs to measure the height of a flagpole. She is 6 feet tall. If she finds that she stands 12 feet from the base of a flagpole, the top of her head touches the wire holding the flagpole up. The wire is anchored 15 feet from the base of the pole. How tall is the pole? All right, let's try to draw the diagram. So we've got a pole, and there's a wire holding the pole up. So the wire will go down to the ground, and we've got our ground. All right, Sarah's standing somewhere. Let's put her here. And when we draw her head touches the top of the pole. Here, we'll put a circle at the top so it looks like a pole. All right, she's 6 feet tall, so let's put a 6 there. She finds that if she stands 12 feet from the base of the flagpole, so this would be 12 feet, her head touches the top of the wire holding the flagpole up. The wire is anchored 15 feet from the base of the pole. So here's the anchor, there's the base of the pole, and this is 15 feet. How tall is the pole? We want to find this distance. All right, so we do have two similar triangles here. Let's see if we can pick them out. We've got a really small triangle here with Sarah and the anchor. So I'm going to draw that. We've got this small triangle. With 6, and we know information about this distance. From here to here is 12 feet, and from here to here is 15, so that makes this 3 feet. And we've got a big triangle. In which we know the bottom is 15 feet. And we don't know the pole. So there's our two similar triangles. 3, 6, 15, and something. And what's neat is we've worked through this whole procedure, but you might be able to find the answer by inspection because sometimes it's actually pretty clear what the answer is going to be. If these two sides are similar, 3 times something gives us 15. The answer is 5. 3 times 5 gives us 15. So this triangle is 5 times bigger than this triangle, which means that this side is going to be 5 times bigger than this side. Well, 5 times 6 is 30. So our answer is actually going to be 30. I'm going to do all the math to prove it to you, but the answer is 30. Sometimes we can just see the answer by inspection. That's how similar triangles work. All right, let's label. I'm going to call this A, B, C. We call this D, E, F. So we've got triangle A, B, C, similar to triangle D, E, F. That's step 1. Step 2, we want to find EF. So let's write our pairs. We've got AB and DE we know nothing about, so let's start with AC and DF. Actually, let's start with the one we don't know, EF. EF and BC. And DF and AC. So EF we don't know, BC we do know, 6. DF we know is 15, and AC we know is 3. So now to solve this, we just bring the 6 up and multiply, and then divide by 3. 15 times 6 divided by 3 is EF. Keep in mind I said the answer was 30. Well, let's see. 15 times 6 is 90, divided by 3 is 30. And we've got 30 feet. So we can say, therefore, a pole is 30 feet tall. All right, that's using similar triangles to solve word problems. And that's it for 6.3, and actually that's it for similar triangles. The next few lessons we're going to start moving on with some more trigonometry that don't involve similar triangles. Thanks for watching, and I'll see you in 6.4.